Okay, so I'm recording now. Welcome to our first tutorial. Just a couple things I'll mention and we'll get right into it. I did have a question before I hit record. Will the first and second tutorial be the same? No. Um, Tutorial number one, I'm going to go through some things. Tutorial number two, I'm going to basically answer any last minute questions you guys have. So what I'm saying is it would be good to go to both or watch both on YouTube. They're not going to be the same. So assuming you guys can see my screen, I know you can, or I hope you can. Some information about your final. I will be in the room, so I'll be there, as well as the other instructor, Robin. So you guys will have two instructors in there that can help you. But with COVID, we can't help too much because of social distancing. But it's a longer exam, but it's quite easy. I've been teaching this for 10 years 10 12 years, I don't know, but it's a pretty easy exam. There are a number of questions, but you've all seen them before. You've seen them in your first test, your second test. They are all outside my office. I cannot put them on D2L, but you can grab those tests outside my office. I highly recommend you guys grab test number 1 and 2. They're in my door. Your exam is, of course, April 11th at 8 a.m. in the female gym, so be on time. Make sure you're there at least 7:30. Iman, you raise your hand. You have a question?
So, did you change the time for chemistry? Because some of the other subjects, they just said it's directly in the exam room, that it's 2 hours instead of 3. Would that happen to chemistry as well?
No, chemistry will give you the full 3 hours.
Okay.
Yeah, that's a really good question. So what happened with the COVID rules is some exams, because they're only worth maybe 20 or 30%, they could be 2 hours. Our exam is worth a lot more. It's worth 50%, and we are allowed to have the full 3 hours. So you guys can take the complete 3 hours to do this exam. But I am going to warn you, and I'm glad you brought that up. Some people during test number 2 went way too long. We cannot let you stay more than 3 hours in the final. So work fast, work hard, do the questions first, get them out of the way. But after 3 hours, you do have to go. So it's Sunday, April 11th, 8 a.m. in the female gym. Make sure you please bring a pen or pencil. You must have your own calculator, face mask, shield. Other things that I should mention, but you guys know this anyways, but bring your college ID. You can bring in a bottle of water. You just need to take the label off. Is there a final exam review? I'm right here. Yes, I'm going to kind of go through that today. And then finally at the bottom, are there tutorials? Yes, there's one right now, and there's one on Saturday. So let's just open up this final exam review and have a little look at it. This exam is on the entire course, so you'll look at polymers, thermochem, rates, acid bases, and electrochem, and then that unit 6 where I'll talk about unit 6 at the end. I've already talked about unit 6 before I hit record because there was a couple questions, but I'll cover that right at the end. Wink, wink, pick up a copy of your first test from my door. I'll write my door number on the page in a minute, but your first test, well, here, let me get my pen going. If you review test number 1, you will have a very good idea for these 2 units. If you review test number 2, you'll have a very good idea for these 2 units. Highly recommend you pick up your tests outside my office, 7242A. Unit 5, basically it covers whatever we've done in class, which I'll scroll down to in the notes here. Okay, any questions before I look at the format and Unit 1.
Sir, can we ask questions about our test one?
Yeah, for sure.
Okay, thank you, sir.
No problem. Like, let me know, raise your hand, type them in the chat, whatever you want. I don't know if I have if test one in front of me, but yeah, if you ask me a question, I can answer it. Hold on here now. I just want to make sure I have a copy of test one that I can bring up. That was so long ago. Just give me 1 second. Sorry, I didn't want to have a big long pause, but I didn't expect this question. But it is a good question. Test number 1. Okay. Nope, that's not the right one. All right. Okay. I can bring up or I have a copy of test number 1 here. But anyways, so the format. The format of your exam, there's 2 parts. There's multiple choice. There's 20 of them, and then there's short answer. For your short answer, give me 1 second. I'm going to get the exact number here. Oops. Hold on now. I should have had this open at the beginning, but I had a meeting just before this. I don't know why I'm getting so many notifications. Anyways, sorry. So for your short answer, there are 14 questions. So you have, I'll write this on the slide, you have 20 multiple choice and 14 short answer. And when I say short answer, some of them are, very short, what you would expect. So a titration, calculating the or finding the rate constant, finding the equilibrium, Le Chatelier's principle, things like that. So it's not too bad. Oh, Hess's law. We haven't talked about Hess's law in a long time. Okay, so and remember at the very bottom of this, it says, remember at the very end, question number 14, the last question, you only do one of them. So health science or engineering will do just one of them. To review, if I were you guys, here's what I would review first. I would start with your first 2 tests. Then I would probably, I wouldn't bother with labs. I would look at worksheets and answers as well. And then you could always look at your slides or your notes. So if I could rank them, I would say study your tests, then check out some worksheets, and then you could look at your notes. That will basically cover everything. There is nothing on this exam that we have not done in class or on a test. Nothing. There's no surprises. The only one that you might not have seen in class is Unit 6, because that's a self-guided unit, and we can talk about that at the end. So Unit 1, it's been months, right? January when we first met, you did hydrocarbons, alkanes, alkenes, alkynes, and aromatics. You need to be familiar with the first 10 alkanes. So methane up to decane. Don't forget about your functional groups. So alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, amines, and amides. Yeah, don't forget about alkanes. Oh, Nora asked me if I'm recording. I think I am, right? Yes, okay, good. There's, to be honest, there's not much to teach you about this page, because this is straight memorization. Alkanes have single bonds, alkenes have double, alkynes have triple, aromatics are conjugate rings with double bonds in them. Well, that's not the definition. That it's not just a double bond, it's a special type of double bond. Okay, that would be an aromatic. Functional groups, you're just going to have to memorize them. There's a couple questions about, or like, well, there's one short answer question where you have to identify functional groups. Pretty straightforward. I recommend for any of my engineering students going into 2420, definitely make sure you know your functional groups. Okay, know your reactions. I know you guys had some struggle with this, but make sure you know your organic reactions. And in particular, this is one that you did in your first lab. This is definitely one that I would know, the esterification. When you add together an alcohol and a carboxylic acid, they bond together and they leave a water molecule to the side. What else? Yeah, does anybody have any questions on that?
No question.
No question. Okay. Here, since I'm being nice, this is another good one to know. If there were two that I would know, it would be these two. Did somebody have a question? Like, I didn't hear.
Yes, sir. Do
Yes.
we have to know the properties for?
Properties. That's a good question. Let me see. No. No, you don't. So there's really no multiple choice or question about the properties that I can see. You will, sorry guys, I'm just drinking some water here. You guys will definitely need to know, like my engineering people who I hope I can teach you again someday in 2420. You will really get into the properties there, but I don't know much about med science after the first two courses, so but I can really speak for my engineers' properties for sure. Okay. Oh, let me check the chat. Okay, good question in the chat from Aman. So I mentioned two of these you should know. Yeah, you have to like answer the write the products. Okay, and a really easy way to remember or like to get some marks is, well, when you mix acid with an amine, one of the products, like this is one of the easiest reactions. I love this one because all that happens is one hydrogen gets stuck here to form NH3 and then Cl goes off by itself. Really easy mark. Esterification, you're always going to get a water. That's an easy mark as well. Actually, in the lab, we used to call this, or you might have called this condensation reactions. Condensation is when water is formed. So carboxylic acid and an alcohol form an ester, which is a condensation reaction. I definitely recommend just practicing that, reviewing that. And guys, I want to stress something that I think every student should know. You might not know everything. Now, I think a few of you here, I'm looking at the names of the people here. I think some of you here might know everything. You probably know more than me. But don't worry, like if there's something you really don't know and you can't figure it out and we can't cover it in the tutorial, the good thing about a final exam is everything's only worth like 1% or 2%. So for example, balancing redox and acid, you just can't figure it out. It's worth 4%. It's not, you're not going to fail, you know. That's something I always think about when I write a final. You know, if there's 15 questions and I don't know one, I can still get a 90. So anyways, just a word of advice. This is a slide I really want to cover because I want to make sure you're focused with chapter 1. Let me just check the chat before I move on. Oh, I know, Aman. We all want an A, and I have no doubt that most of you people will get an A. You guys are like one of the best classes I've ever had. I think getting an 80 will be easy for a lot of you. You know, when I look at my attendance, there's been about 15 to 18 students who never miss a class. I don't think you guys will be worried to get an A. But anyways, and for the people listening on YouTube later, if you didn't attend a lot of classes, you can still get an A too, don't worry. Okay, So polymers, how do polymers form? And then some information about polymers. This was a particular question that we looked at on test number 1. Check out test number 1 for that question, the difference between thermoplastics and thermosetting plastics. I won't get too much into details here. It's a very easy question, but one of these polymers cannot be recycled, meaning when you heat it up, it breaks apart. So, kind of make sure you know that one. For what else do we have? Like for homopolymer and copolymer. Homo means the same, co means kind of different or pairs or partners. Like think about a co-worker. Co-workers are 2 to 3 different people stuck together. Homogeneous solutions are the same solution. So a homopolymer would have a polymer consisting of one type of polymer. A copolymer would be mixed. It could have 2 or 3, what we would call a monomer. Do you remember that word, monomer? A monomer is the building block of a polymer. So it's the pieces that fit together. So a homopolymer is made up of one repeating monomer. Okay, I can give you an example of that, a good example of a homopolymer. I think this would be PVC. So a good example of a homopolymer would be like if I took this chemical, oh, sorry, I gotta, let me clear that. Let me do that again. So if I took this polymer, this is how PVC is made, and I add it to another one of these polymers, okay, what happens is, so these are monomers. I didn't mean to say polymer just then. These are monomers. And what happens with this is really cool, is that the double bonds break and they decide to stick together. So what happens is this double bond breaks and forms a bond here. This double bond breaks and forms a bond to another one, and it goes on and on and on. This would be an example of addition polymerization, and this would be a homopolymer. A copolymer would be kind of like if we went up above and we looked at a condensation reaction, which is what I just talked about a minute ago. Okay, so that's about what I would know from this slide. It says here talking about melting points and boiling points. I don't think you need to worry about that in this course or this exam. MP or BP means melting or boiling points. That will become really important in a future course. Okay, I'm going to stop talking for 1 second because I got some hands going up and I got some chat questions going on. Yes. Okay. So Aman, I'm happy you did that. One thing I'll mention, actually, that I'm glad you brought that up, is Aman says, and Yasmin, I'll get to you in 1 second about your hand. Yasmin says, or sorry, Aman says, since this question, I think you're talking about the thermo and thermoset. Since this question was a written answer, you tried your best. Well, in this exam, the only written answer is about chapter 6. And don't ask me about chapter 6 yet. Like we'll get to chapter 6 at the end of this, but the only written answer in the whole thing is chapter 6. DNA is a good example of a copolymer as well. That just talking about the chat there. Okay, Yasmin, do you have a question?
Yes, I do, sir. Sorry. There's a question in test 1. It went like, which polymer would have the higher melting point? How would we? It's question number 3 actually. How
Okay.
would we differentiate it?
Okay, good question. Let me just get it. Was it a multiple? No, question 3.
It was a written explanation.
Right. Okay. Well, I just kind of mentioned that melting and boiling points won't really be a factor here, that you'll talk about that in another course. But the answer to question 3 on test number 1 is this is review from chemistry 1120. When you think about boiling points, you have to think about intermolecular forces. And if you remember from chemistry 1120, there's London dispersion, dipole-dipole, and hydrogen bonding. And the answer to number 3 is the compound with sulfur has more electrons. I'm sorry for everybody who can't see this question. I don't have it on my actual computer. I have it on another screen here. But question number 3, test number 1, the answer is the compound with sulfur because it has more electrons than the compound with oxygen. Okay, and again, I apologize for people who can't see the test, but if you want to go grab it, number 3, sulfur has more electrons than oxygen, so sulfur has the higher melting point. And that's because of London dispersion.
Okay, sir. Thank
Cool.
you.
All right. Okay, so that's it for chapter 1. Pretty easy study guide there, right? Not a lot to know from chapter 1, nothing too crazy. Chapter 2. Chapter 2, guys, is going to be mostly calculations. I tell my students this every year, and honestly, this is one of the best questions every year. I can tell you right now, you will have a calorimeter, and you will have Hess's law. That's it. Well, I'm not saying that's it, but in terms of like your short answer questions, and I don't mind telling students this every year, calorimeter, think about your labs. If you can remember all the way back in January, lab number 2 and 3, and you do not have to study your labs, don't worry, but you did a calorimeter in lab 2 or lab 1, whatever. You did a Hess's law in lab 3. Make sure you know those. Check out worksheets, check out my notes, like whatever you want to do, but make sure you know those. That's all I'm going to say about unit 2, because guys, that's the most important part. Before I move on, would anybody like to see a calorimeter or a Hess's law question? Okay, I'll move on. I will move on. I'm kind of happy that nobody said anything, because they're easy. They're repetitive. We've done a million of them. There's lots of hints on these slides. For calorimetry, make sure you remember that Q system equals negative Q surroundings. So remember, like, calorimeters have the same steps. You find the Q of the system, you change it to Q of the surroundings by flipping the sign, and then you divide it by the number of moles. 3 steps. So calculate Q, change the sign, divide by moles. Hess's law, very easy question. Hess's law is easy if you know what to do. Remember, you multiply equations or you flip equations so that they cancel to get the overall. All right, I got a feeling you guys are going to ask me more about chapter 5 or something. I got a weird feeling in my belly. Okay, yes.
So I actually have 2 questions. The first one, if we have the word dissolve, that means it mixed, right?
Okay, yeah, okay. Good question. So to answer your first question, there are 2 types of. Can you mute yourself? I can hear myself repeating. Sorry, it's not. I didn't want to be rude, but I could hear myself in my headphones. So there are 2 types of calorimeters. You can have a calorimeter where let's see what I can do here. How can I do this? I want to open up a blank screen. Okay, give me 1 second. This will be worth it, guys. Trust me. I'm going to open up a blank screen to draw with for you. Okay, so present. You'd think after 1 year I'd be faster at this. Okay. So the question was, if you know you are doing a calorimeter, it's always two things being added together. It's either like a piece of metal being added to water or something that dissolves being added to water. And this is really the only place you can mess this up. So two situations. We have a calorimeter with some water where we drop a chunk of metal in there, or I don't know. I don't mean I shouldn't even. I don't know why I'm putting stars there. Or we put in like another liquid and it's a mixture. So it's like, you know, imagine we put in NaOH aqueous. We put that in there. This is of course water. Well, in the situation with the metal, Q is M of the metal, like we're talking about the system. C of the metal, and then delta T. Okay, or, you know, or, sorry, I guess I should say more specifically, your first step would be to find the Q of the water. So the Q of the water would be the mass of just the water times the heat capacity of just the water times delta T. That would be your first step. So why am I showing you this? If it's a mixture, your first step would be Q of the mixture, which is the mass total times the heat capacity of water. We still use water. I remember teaching you guys back in January, and there were some questions like, why are we using water if it's a mixture? That's just one of the things we ignore in chemistry. It's like in physics, you ignore sometimes wind resistance. We still use water. So to answer your question, if it's a mixture, get the total mass. If it's not a mixture, meaning we drop a piece of metal in, don't add metal. Okay. Did you have, you said you had two questions, so what was your other one?
Sir, the other one related to the Hess law.
Okay, okay.
Sir, in the test one, I was confused about one thing because when we are looking, for example, to the water, I found that the water in the two equation in the product side. So I was confused which one should I choose. But eventually I got it right, but I'm still confused about it.
Okay, the answer to your question is neither. You choose neither because if okay, let me write that question down. So guys, this is the question from test number 1. So the question is, you're given an overall and it's 3C solid plus 4H2O gas. Sorry, I'm talking to myself. Goes to make propane. I really should just try to bring up test 1, shouldn't I? Oh well, but the problem is I'm using two computers. I have like a work computer and then I have like a project computer. And anyways, give me a second to write this out. I'm just going to be like kind of quiet for a second here, guys. Just give me, I just want to write this out. It won't take much longer. Okay. Okay, I'm almost done because the next ones are very short. Sorry, one more. And for anybody who, like, I'm going to be honest, I know that there's people that are going to watch this tutorial who didn't attend many classes or struggled with the first test. This is going to look crazy to you, but I highly recommend practicing it. Let me write this again here. Okay, so the question was, what do you do with the water? Well, ignore, oh, I lied to you. Yeah, sorry, I didn't lie to you. Ignore the water. The water is not in the overall equation. So let me explain. The only chemicals I care about is the carbon. Okay. I care about the hydrogen. I care about the, I'm running out of nice colors, the propane. Okay. Oh, sorry, that's pretty ugly. What you're trying to do is you're trying to match each chemical in each equation to equal the overall. Okay, so what I'm going to do, like, okay, let's look at the propane. In the reaction, if I call these, 1, 2, 3, in reaction 1, the propane is a reactant, it's on the left. But in the overall, it's on the right. So I'm going to flip this equation. In reaction 2, we have carbon on the left and carbon on the left in the overall. Everything's cool with the carbon, except I need to multiply it by 3. Let me pick a different color. Let's go with purple today. So I'm going to flip this equation. I'm going to multiply this equation by 3. And then in the last one, number 3, I have, this is the hardest one of all of them. In the overall, the hydrogen is on the left, and there's 4 of them. In reaction 3, the hydrogen's on the right, and there's 2 of them. So I'm going to have to flip and multiply by 2. Okay, so to answer your question, very long, I know, but who cares about the hydrogen or the carbon or the oxygen? We only care about the chemicals in here. If you match these chemicals to the chemicals in these equations, everything else will cancel. It will work out. It always works out. I secretly love Hess's law. Okay, does that answer your question?
Yes, sir.
All right, cool. Cool. Okay. Sorry. Okay, hold on now. Okay, let's look at Unit 3. Unit 3, rates of reaction. So Unit 3 has 3 pages on it, and let's kind of go over it. Okay, let's think about some factors that affect reaction rate. This is a pretty easy one. Excuse me. Basically, if you increase concentration, increase pressure, increase temperature, you're going to make it go faster. So here, if you increase 3 of these things, the rate will go up. Catalyst, you guys know, increases the rate. Particle size, typically it's the smaller the particle, the faster it is.
Sorry, you mean powder?
Sorry?
You mean powder?
Powder, yes. So like a particle size, like, I don't know, see, I'm going to sound like I'm an old man here. When I was younger and I would drink like tea or coffee, they would give us sugar cubes, like a 1 by 1 centimeter cube of sugar. And you'd have to put it in your coffee and you have to stir it for a minute to get it to dissolve. But now, when you go to Tim Hortons or Starbucks, they give you powdered sugar. Well, a baker would never call it powdered sugar, but you know what I mean, little crystals of sugar. So powders or small particles react faster. Increased concentration, increased pressure, increased temperature reacts faster. Catalyst, guys, definitely, wink, 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 wink. Definitely know what a catalyst is and what it does. A catalyst, don't forget, it makes reactions go faster and it lowers the activation energy. What is activation energy? Remember, it's the energy it takes for a reaction to happen. You know, a lot of reactions don't happen with a bit of help. So that help would be the activation energy, and a catalyst lowers that. You will definitely get a rate law question. Okay. Okay, so guys, I got a question in the chat, but let me, no, I'll do that now. Okay, because you're asking me this and I literally just mentioned it. So I'm talking about rate law. Make sure you know the rate law. And then the question in the chat from Yasmin, I don't know if you guys will be able to see it on YouTube, but she says, I got this question wrong on the test. How do you write the rate law for this equation? And the equation you're giving me, first of all, I don't have enough information, but we'll get to that in 1 minute. The equation I'm given is this. How do you write the rate law for that? Well, you cannot write the rate law for this until you tell me the order of these reactants. I need to know the order. X and Y are the orders. So again, so if you read the chat, again, on YouTube, you might not be able to see it. Yasmin says that N2 is 0 order and O2 is first order. Okay, so my rate law would be rate equals K. K is a constant. It's given to you in the question, times the concentration of N2 to the power of 0 times the concentration of O2 to the power of 1. The coefficients have nothing to do with this. The coefficients are for equilibrium. They're not for rate law. That's wink, wink, a very good question to know for your final. Obviously, it's not the same question, but you know, we're going to give you a rate law question. We'll tell you if it's 0 first or second order. You fill it in. You're welcome, Yasmin. That's good. And guys, so the next question after this, typically, part A is to write the rate law. Part B is to put numbers into it and just put it in on your calculator. I will tell you this. If any of you guys are having problems with your calculators, you know, you're not sure how to enter an exponent or a logarithm, you know, logarithms for pH, put your hand up. I'll be there in the gym. Again, I'm going to try to social distance, but if you do have, like, meaning I probably can't touch your calculator, but just let me know if you need help with logarithms or exponentials. There's no KP, Aisha. It's only KC. Sorry, there's a question in the chat about KP. KP is exactly the same as KC, to answer your question. Exactly the same. It refers to the pressure of gas, where you would just, you do the same thing, products over reactants. Actually, that's a good question from Aisha. So the question was, how do you calculate KP? The answer to how to calculate KP, KC, KA, KSP, it's all the same. It's the concentration of the products and reactants. No solids or liquids. Sorry, that took me my brain a minute to catch up with my mouth. No solids or liquids in KC, KP, KA, and never put them in. But yeah, there you go. Okay. I mean, this document is basically one big giant wink, wink. I would look at this question from test number 2 about half-life. It was a multiple choice on test number 2. This, I think, I don't have test number 2, but this would be good to know for test number, from test 2. This is called a potential energy diagram. I don't have much to say about that, actually. it's losing energy, so it's exothermic. It's giving energy away to the environment. If it was endothermic, it would look like this. Okay. This at the top is your transition state. Your activation energy is the distance between the reactants and the top. Like your activation energy is the energy it takes to make it happen. So in order to make this happen, you need to get to the top of that hill. So activation energy, the energy it takes to make that happen. All right, moving on. Okay, so I'm tired already. So we're only at unit 3, but I mean, you guys know that you're going to see this again. And honestly, this is one of the easiest questions. You will have to write a KC, and you might have to do a calculation with that. We did that on test 2. Definitely know that. Le Chatelier's principle from test 2. You guys are going to need to know that. I cannot stress to you enough how important it is to study your tests. Oh, that's a great question. So in the chat, I'll just read it. So I am always confused on the effect of increasing the volume has on a reaction. This is a question that really, and sorry, we're talking about Le Chatelier's principle. This is a question that really messed up people on test number 2. So let me give you 2 examples. Okay, so in each example, we're going to increase the volume. Now, increase in volume means decrease in pressure, by the way. They are inversely related. Sorry, one second. I just got to check something on my phone here. Sorry, guys, one second. Okay, so let me give you a few examples. So I could give you this equation. So let's say 2A aqueous. I'm just like, these aren't chemicals. It's just like, you know, I'm going to use A and B. Aqueous goes to 2C aqueous. Okay. Well, if I increase the volume, there is no change. It does not shift left or right. Volume only affects gases. You guys learned about this in chemistry 1120. Aqueous solutions and solids, they are not compressible. Gases are compressible, meaning changes in volume affect gases. So if I gave you the same question, but the question had gases, oh, this should be in equilibrium, by the way, sorry. Now we have to start thinking. The way that it works for gases is if you increase the volume, it favors the side, because again, this is big, right? Think about a big classroom. Think about writing final exams. So you guys are gas molecules, and there's so many of you guys, we can't put you into a classroom. So we increase the volume. Increasing the volume favors the side with the most mole of gas. Now, you do not have to calculate moles. We just add up 3 moles on this side, you know, 2 plus 1, and 2 moles on this side. So if I increase the volume, it favors big side. It would shift left. Okay, does that make sense? I'm just reading the chat there. Yeah, Yasmin, read the questions properly, and I'm glad that makes sense, Aisha, or I think you said that it makes sense. One question in the chat, you guys let me know. Quick question. What happens when you add a catalyst to an equilibrium? Left, right, no change.
No change.
No change.
No change.
Exactly, perfect. Aman, I just like talked for like 5 minutes on that. What do you, I can't say everything again. It's on YouTube if you want to watch it again, but is there anything specific I can answer? Big volume favors most moles of gas. Small volume, least moles of gas. Is that cool? All right. Okay, so no, in the chat it says if we increase the volume, it will shift to the left. Only in this equation. If you increase the volume, it shifts to the side with the most moles of gas. If you decrease the volume, it shifts to the side with the least moles of gas. But every equation is different. Not all equations have all of the moles on the left, right? It depends on the equation. And thank you guys who said no change. I'm glad. That's a good thing to know. All right, Aman, does that make sense? All right, I'm going to move on.
Sir,
Yes?
could you please explain when the equilibrium shifts?
I need a more specific question.
For example, we had so many questions, right, regarding equilibrium.
Yes?
Could you please explain that?
No, I need a more specific question. Sorry. I can't reteach a whole unit. I mean, you got to ask me something.
Okay, sir, I will check in a minute.
Yeah, check in a minute, have a little look at it, but I need a specific question because like I can't, that teaching Le Chatelier's principle would take me 30 minutes. So I need like, and I don't mean to be rude, like I love to answer your questions. Maybe after class you can stick around, but I can't reteach a whole topic. I'm so confused with this PowerPoint. Clear screen, okay. So sorry, I stopped sharing there. Into the next page. I will recommend, I really hope I didn't sound rude there. I'm not trying to be rude. It's just time is precious for us all.
No, sir, it's okay.
Okay, and just like I think your notes really, in my YouTube videos and your notes, really it will explain Le Chatelier's very well. It has to do with like the balance, but it's a pretty big topic. I'm forgetting how to share my screen. Hold on here, Zoom. Okay, chapter 4. We're getting there. We're almost done. Well, you know, we're almost done this part. Chapter 4. Definitely know I mean, you guys know you're going to get this. Please study and know what an acid and base are, or more specifically, what a Bronsted-Lowry and a what a Bronsted-Lowry acid is and a Bronsted-Lowry base is. Acids donate protons, bases accept protons. This was a question on test 2. Could be a good wink wink. Sorry, that's a weird looking wink face. Amphiprotic, this is a chemical that is both acid and base. And this would be good to know. Ka, large Ka equals strong acid, small equals weak. All right, let me check the chat. Okay, so I do have a specific question about equilibrium. This is amazing because every class is different, and it might have just been how I approached this concept this year. I've always said in the past, and again, you guys are probably the smartest chemistry 1120 class I think I've ever had, which is saying something because we're doing this by distance. You know, it's completely different when I'm in classroom. It's typically better when I'm in classroom, and you guys are so good. But what I'm trying to say is, the question I'm asked about equilibrium multiple times surprises me because in previous years, Equilibrium has been like the question everybody gets right, but then the minute I throw a calorimeter at them, it's like everybody gets a 0. So it's kind of interesting about the difference of classes, how one class is strong in one thing and one class is strong in something else. And you know what, it might have just been how I taught it over distance. Okay, anyways, here we go. Aisha had a question. What about these temperature changes? When you're having an equilibrium and the temperature is going to change. Well, that's a difficult question to just like, there's no method I can teach you to just like there's no simple formula. You really have to use your brain. So let's think about an endothermic equation. And let's think about, here we're going to make it hot. So, or like, you know what I mean? We're going to warm it up. We're going to increase heat. And then let's think about an endothermic equation. And now I'm going to be real clever here. We're going to try to be, oh no. Okay, good. Sorry guys. Pen issues. The Zoom control panel is right over the thing that I need. It's driving me crazy. Okay, here we go. Cold. So we'll do the same thing. So heat plus A, equilibrium with B. So that would be endothermic, exothermic. Okay. So all of these have different answers because you really need to think about what's happening to the balance of the system. If I increase heat here, I have too much heat.
Sir,
Yes?
we can't see.
Oh, sorry.
Did you write something?
I wrote a lot of things. Uh-oh. Sorry. Okay, so here you go. You can see this now, right?
Yeah.
Yeah? Okay. So that's going to look really bad on my YouTube. Whoops. Anyways, so here we have an endothermic reaction. And I'm going to increase the heat. Well, I have too much heat. What does your body do when you get too warm? You start to sweat. Well, when a chemical equation gets too warm, it tries to shift away from that heat. So in this case, it shifts right. In this case, on the bottom, in an exothermic reaction, it shifts left. When your body gets too warm, you sweat. It tries to remove the heat. Now, and I don't know if this happens to you guys too much in Qatar, but if you're too cold, what does your body do? Well, you shiver, you shake. Your body's trying to warm up by increasing the kinetic energy, we could say. So if I get cold, the heat term goes down. Your body tries to fix it by going left. Well, in this case, sorry, I should not have said left there. Your body tries to fix it by shifting towards the left in an endothermic reaction. In this reaction, if I lose heat on an exothermic, it shifts over here to get more heat. Whew, okay, does that make sense?
Yes.
All right, perfect. And Ahmed mentions he follows the delta H. I mean, I think if you're talking about equilibrium for heat and cold, that's right. Like this here is your enthalpy, basically, your delta H. That's right. Sorry, Ahmed, I didn't see you come in. Hello. Actually, I haven't even looked at the class list since like an hour ago. So we got Abdul Rahman, Ahmed, Aisha, Iman, Aaron, Walid. I can never say your name right. And Yasmin. Hello. Okay. Moving on. Discard. All right. What was I gonna do? Go back to my notes. Sorry, I'm talking to myself like a crazy person. Share my screen. Okay, so that covers this slide. Know the definition of acids and bases. I don't know if you guys need to know anything about a buffer. No, I don't see anything about buffers on your final, but I will tell you, just because, especially for my medical science students, buffers are important. for med science. Actually, buffers are important for engineers as well. I guess it's important for everybody. What a buffer does is it's a chemical that fights changes in pH. So it helps regulate or control the pH. So in a delicate engineering system where you might want, acid will corrode metals, you probably would use a buffer to keep the pH, neutral or basic. Maybe not basic, because that would have other problems with scaling maybe. In med science, buffers are in your blood, right? So if you've heard of acidosis or alkalosis, I'm not a biologist, but that's related to body or blood pH, related to breathing as well. Anyways, you don't need to know buffers, but I always find them interesting. Okay, I'm running out of steam here, but I'm still going to keep going, don't worry, but I'm going to skip past this slide. Now, this is important. You should know how to calculate basically any, well, I'll show you what you should need. I'll circle what you need to calculate. You should know how to calculate or use this formula and this formula. Okay. For good practice, maybe over the weekend. I know you guys are busy. I think you guys have stats on Saturday, which when I did stats, I didn't do too well. And I was good at math. It's just, my brain plus stats didn't work. But I'm going to move on. Okay. If you guys have questions about this, you can email me or send me, or sorry, come to the tutorial on Saturday. I'm going to move on because again, I'm expecting more questions coming up in a minute. So I really want to focus on the big ones. This is not a big question, but you should know how to use those calculations. Okay, guys, I'm telling you now, slide 11. Yeah, okay, so I can definitely do that. I'll definitely do solubility, and I'll tell you this now, maybe we could do this on Saturday as well. There are some classic questions on a chemistry 1121 exam, classic. There is calorimeters, Hess's law, acid-base titrations, balancing a redox, which I expect people are going to ask me at the end. Make sure you guys are comfortable with titration. Now, guys, here's the thing about a titration. It is literally 1120. There is nothing new about an acid-base titration that you guys didn't know in chemistry 1120. Step 1, find moles. Step 2, use your mole ratio. Step 3, calculate the concentration. Every single titration question in 1121, they get more difficult later on in other chemistry courses, but every single titration is the same. Find moles, use your mole ratio, calculate concentration. Everything's the same, 3 steps. I'm going to leave that for now. Okay, so this slide had some confusion, and I think it was my fault. We did this right at the end of class one day, and there was a confusion especially about this one. Now, I particularly left a question like this. Sorry, I'm trying to circle the bottom. I particularly left a question like this one off test number 2 because there was confusion right at the end of class. Let's talk about this. So to write a dissociation equation for solubility, again, definitely something I would look at. Guys, it's the same as K. K is the concentration of your products over the concentration of your reactants. But what's interesting with solubility is there's no reactants. There's no reactants because they are solid. So the solubility or the equilibrium expression is basically K is equal to the products. So imagine an equation like this. So easy. K equals concentration of your silver times your concentration of chlorine, no problem. Well, in an equation like this, there's a 2 in front. And the 2 is really where we got confused, and we missed one number in the lecture. We missed that little 2 there. So, you know, let's do this one. I'll write it down for you. So let me erase the screen here. So we're looking at this equilibrium. K is going to be the concentration of Pb2 plus times the concentration of Cl minus squared. That's normal. We did this in chapter 3. There's, you know, nothing on the bottom. We don't put solids in our equations. Now the problem is that because there's one of these, we would call this X, S or X. I like to call it X, but I mean, it's just a variable. I don't care what you could call it, P or Q or whatever you want. But we call it, you know, I would call this X. I'm a big math fan. I would call it X. Because this has a 2 here, we would call this 2X. So I put this number here. I put this number in here. So KSP becomes X times 2X squared, which means we end up getting 4X cubed. And now you have to solve for this.
Sir, why square?
I square it because of the 2. This is from unit 3, right? The 2 in front. Do you see that?
Yeah.
Does that make sense?
So why is the 2 as coefficient and as well as the exponent?
We use the 2 because there's a 2. So the 2 means we're going to square it, and we're going to write 2s or 2x. Again, I'm a fan of x, but it doesn't really matter. So that 2 means we square it, and we put a 2 there in front of it. So it leaves us with this guy, 4x cubed, which is just a math question basically at this point. All right, does that make sense? Okay, I'm gonna move on, guys. I'm gonna go for about 15 more minutes. Anything I don't get finished now, I can do on Saturday night. I will obviously record that and put it up as well. I hopefully Saturday night will be like, basically I've been through almost everything. I am going to do some chapter 5 questions, by the way. But yeah, after I do, 15 more minutes after I do a couple questions from chapter 5, there shouldn't be much left for Saturday night. And then maybe you guys can ask me any last minute questions. Okay, so balancing redox in acid, I can tell you now that you can ignore this. We are doing our reactions in acid, not base. Okay, so make sure. Oops. Ah, man, my pen. Make sure you know this. Okay. Any questions on balancing an acid? Okay. Oh, wait. Not now. Okay, I love that answer. That's my favorite answer. Not now means we don't have to worry about it now, but maybe Saturday night, some people will ask me. I got a feeling Saturday night might be a bit chaotic because Saturday night I might have more students because people are freaking out about the final exam. So I got a feeling Saturday night people will ask that. But guys, get rid of, you don't need to study this. We were kind of running out of time at the end, and everything was a bit of a rush, so I really focused on what was important. Okay, definitely know this. You should know how to calculate E cell and how to label a cell. That's about it. So know how to calculate E cell and know how to calculate it. I'll tell you right now that I mentioned this in class. We're going to deal with galvanic cells. So a little hint, wink, 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 wink. When you have to sketch a cell, your E cell has to be positive. you're not going to draw an electrolytic cell. Whew. Thank you, Yasmin. Yeah, sorry, I didn't read that chat in time, but yeah, I think Saturday going to be crazy. But anyways, I'm trying to think. Whoa, I got a lot of, so like I'm teaching you guys, but I'm also doing some courses on my own as a student. So I'm a teacher and a student. I'm trying to think if I have anything on Saturday night for my course, but it doesn't matter. I'll still stick with you guys. Okay, there's 2 pages left. Okay, so this was the last question we did. This was the very end, last question on your YouTube. You will see this will be basically the last, this is one of the last questions on your exam. The question says, how much time in minutes will it take to produce 1.40 grams of aluminum at 2.25 amps in an aqueous solution of aluminum nitrate? This is a distraction. You know, that is meant, it's not meant to distract you, but it's just there because it's kind of part of the electrochemical or electrolytic cell. Scary. Okay. Honestly, because there's 12 minutes, let's look at this one again. And then I'll explain to you guys chapter 6 again, because I want people who aren't here listening to this tutorial just to understand how easy this is. This question is worth 6 marks, and it's a giveaway. If you can understand a couple of slides, there's no calculations. It's strictly memorization. This is a self-guided unit, meaning health science students read 1 page or 1 PowerPoint, engineering read another PowerPoint, and I've narrowed it down to you guys to 4 or 5 slides. So just keep that in mind. That is the last question on your exam. It's worth 6 marks. Please, 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 please make sure it's an easy 6 marks. If you're in health science, study this. Engineering, study this. Easy peasy. Okay, let's look at this one for the finale of today. How can I make this bigger? I want to make this full screen because I don't want to rewrite this. It's like I can't find the perfect balance. Oh, here we go. Okay, I can go in one more. Hold on. 2 more. Okay, let's have a look. And you know, I don't mind doing this one because we did it right at the end, and you know, we did a lot that day, and we did a lot in this course. I mean, you know, this is a big course. So how much time, so we're looking for time is T, will it take to produce 1.4 grams of aluminum? So this is our mass. The molar mass of aluminum is on your periodic table. Now, remember, I told you guys, you're never going to have to calculate molar mass. It's going to be given. I didn't lie to you. It's still true. You don't have to calculate the molar mass of aluminum. The molar mass of aluminum is under the aluminum element on the periodic table. Okay, there's no calculation. The reason I'm not giving it to you is because you should be able to, you know, go to the back of your data booklet, find aluminum, call it a day. No multiplying, no adding, nothing. And this is true for all of these questions. All right. So think about your formulas. We have 2 formulas that were new to us. Q is your charge, your coulombs. F is a constant. T is time. I is your amps. C is your charge. Okay. So step number 1. We know we have 1.4 grams of aluminum here. We're trying to see how long it's going to take for that to get produced. Well, step number 1, you need to find your moles of aluminum. And the reason you need to find your moles of aluminum is your goal is to get to this equation that I'm circling. You see that there? I want to find T. I know I. I know I because it's given in the equation. So I is 2.25 amps. I know that. This is your current. I called it amps earlier. I meant current, but same thing. The unit is amps. It's current. So if I want to find T, I need to get Q. So how am I going to get Q? Well, I know that Q is related to the moles of electrons in my half reaction. Okay, so kind of chemistry 1120 review right now. If I can find the moles of aluminum, I can find the moles of electrons. I cannot stress to you enough how important stoichiometry was for you guys in chemistry 1120. We use it in titrations, and we're using it right now. The first two steps in this question, which are worth, half of the marks, is 1120. First, find your moles of aluminum, then use your mole ratio to find your moles of electrons. So let's go down here. Let's look at the calculation. Moles of aluminum, mass over molar mass. I get 0.05 moles. Okay, so I have 0.05 moles of aluminum. All right, step 2. How many electrons do I have then? Well, I know from my equation, sorry, I'm going back up to the equation, guys. There are 3 moles for every 1 mole of aluminum. So I use my mole ratio, 3/1, and I get my moles of electrons. You're halfway there. Honestly, you are halfway there. Step number 3, now that I know moles of electrons, I can use this equation. This equation is your charge is equal to the moles of electrons times F. F is a constant, like I said, it's in your data booklet. If you guys can't find information in your data booklet, like the heat capacity of water or Faraday's constant, I can help you. You can ask me questions in the gym, but don't make me run around too much, because I have a face shield on, and I'll probably melt. But if just remember that any constant you need is in your data booklet. So I'm going to clear all my writing, guys, just so this looks normal. So step 1 is done. We found the moles of electrons in step 2. Step 3, we're going to take that answer and multiply it by the constant, which gives us our charge. And then finally, step 4, I know that time is Q over I. So I put in my number of my charge and my amps, and I am done. I don't care if you convert it to minutes, just give me seconds. I'm happy with seconds, guys. You don't have to convert it to minutes, but this is the answer. Whew. All right. How is everybody doing? Any questions? That was a lot to take in. So any questions, anything?
No questions, sir.
No
for
questions
now.
for now. Don't forget, even though there's a tutorial on Saturday, you can still email me over the weekend. I'll get back to you within the day. If you email me at like 6 in the morning, I might get back to you at 10. If you email me at midnight, I might not get back to you until I wake up, right? But I'll get back to you as quick as I can. Thank you so much. This is going to go right up on YouTube. It'll probably take an hour for everything to kind of render and upload. But I'll see you guys later. Thanks, everybody.
Thank you, sir.
Thank you.
Have a
Take
great
care.
day.
Yes, you too. Have a great day. Goodbye.